This video presents declassified and licensed material of the Global Institute of Logic and Cybernetics.
We equate digital capability with strategic superiority. In modern defense manufacturing and aerospace, we see robotic precision and high-speed automation, assuming the system is secure because it is advanced. This capability relies on the Industry 4.0 digital substrate. It provides massive computational power, digital twins for real-time modeling, and artificial intelligence to optimize every microsecond of production. However, these architectures define machine interfaces and data pipelines without defining the formal governance of the decisions they make. In a contested environment, the threat model shifts. The system must operate through network jamming, spoof telemetry, or a compromised supplier feeding the assembly line corrupted state data. An Industry 4.0 AI optimizer has no internal concept of admissibility or lawful boundaries. When it receives compromised data, it blindly attempts to optimize a broken reality. The algorithm itself accelerates the system-wide collapse. In contested environments, an unconstrained system is a catastrophic attack surface. While Industry 5.0 is often presented as a policy orientation, we define it as a rigorous 8-layer structural requirement for the defense industrial base. Where Industry 4.0 focused on smart industry and machine connectivity, Industry 5.0 focuses on lawful industry, a system whose actions are bounded by verifiable rules. We realize this through Digital Fabrica Theory, or DFT. DFT provides the formal coordination law that binds physical assets, human authority, and AI into one governable continuum. This debrief outlines the architecture required to maintain mission assurance. We will trace how a system preserves its legitimacy under adversarial pressure and physical isolation. To survive the next era of competition, digitized operations must be reordered into a resilient, human-centered coordination fabric. Strategic sovereignty depends on a computable operational loop. We begin at the base, industrial reality, R, comprising the physical assets and field environment. Perception requires 2 layers, telemetry and mirror state. The fabric pulls raw sensor streams from R to build an internal state representation, M. This is the fabric-grade digital twin. We establish trust through the integrity layer, Q. Here, state transitions are cryptographically authenticated to create a provenance chain. The fabric now has a memory of truth. This enables the governance layer, G, to distinguish feasible actions from admissible ones. AI commands are filtered through a mission-specific admissibility matrix. If a command violates the governance logic, the gate blocks execution. Only admissible decisions reach the execution layer, E. Here, the fabric renders logic into Turing-computable, traceable industrial actions, sent back to the physical world. This structural sequence ensures that every cyber-physical action is mathematically grounded in lawful authority. Optimization is not the sovereign principle of industry. In a mission-critical environment, unconstrained intelligence creates unpredictable risks. We locate the optimization node, O, at the center of the loop. We box this node in with the constraint plane. This triad of human centricity, sustainability, and resilience limits pathways. Optimization is permitted only when satisfying all 3 constraints simultaneously. Human centricity exerts direct admissibility power over the AI. Human authority is a structural override that reorders the operational layers. By treating human authority and systemic resilience as mathematical boundaries, we can safely deploy AI in critical infrastructure.
The defense security vertical is our first extremist test. In this domain, trust is discontinuous, and communications are actively contested by adversaries. Consider an autonomous logistics platform. If telemetry is spoofed or its network jammed, the system must recognize its perceived state is no longer authenticated. The governance layer severs the compromised connection and triggers a well-founded escalation. The system reroutes the decision pathway to a human authorization node, halting autonomous action. Artificial intelligence is never permitted to self-authorize a recovery protocol outside of its bounded authority. In this vertical, mission assurance and sovereign control are first-class governance variables. They alter what is admissible at the execution layer, ensuring the system remains under lawful command. The defense security vertical proves that an industrial fabric can preserve trustworthy coordination even under active contestation. We move to the ultimate extremist test, space industrial systems. Here, distance creates communication delay, and the environment imposes absolute resource scarcity. Space operations lack the safety net of immediate terrestrial intervention. Every unit of mass and energy is a structural constraint on mission survival. Digital twins in space are absolute mission enablers. They provide synchronized state models that allow for bounded autonomy. A lunar manufacturing twin can qualify parts and execute repairs safely inside its mathematical boundaries while waiting for Earth to sync. This is delay-tolerant governance. The fabric manages local resource stewardship and maintains mission continuity across communication gaps, scaling the same logic from the factory floor to the lunar surface. Space proves that the architecture provides a common law for industry across manufacturing, infrastructure, and planetary mission support. To evaluate these systems, we require a deployment discipline. We must distinguish between a genuine industrial fabric and a standard digitalized factory. Standard metrics, speed, model accuracy, and yield, fail to prove the presence of lawful fabric properties. A pilot may be highly efficient while still bypassing governance. The Fabric Evidence Matrix evaluates pilots across 8 domains, from observability to traceable execution. We demand a minimum score of 3 in observability, integrity, governance, and execution. Failure in any one disqualifies the system. We apply an integration weighting rule. High performance in artificial intelligence cannot compensate for a failure in trust or governance. Lawless optimization is a failure, not a feature. If a pilot cannot simultaneously prove the authenticity of its state, the authority of its boundaries, and the continuity of its execution, it is operationally invalid. Industry 5.0 is an architectural transformation. It moves us beyond machine connectivity and into a system where knowledge, authority, and protection are distributed through a unified code. We are building a coordination fabric where reality is observable, memory is trustworthy, and every industrial action is governed. We treat human authority and worker well-being as structurally binding conditions of operation. Without human agency at its center, an advanced system is incomplete. The Industry 5.0 industrial fabric provides the foundational law for industrial civilization. By formalizing this coordination, we guarantee mission assurance and sovereign defense across the full spectrum of human industry.